Salam sejahtera and greeting to our lecturer, Dr. Noor Azlan bin Muhammad Aris, lecturer of Signal and System. In this video, we are going to present our assignment group work, which is Signal and System. So firstly I'm going to introduce our group members. So this is our group members. So for introduction, the instruction of this assignment is to do 3 different tasks by using single image. So the task can complete by modifying the C code by using MATLAB. So for the first task is to visualize the original image into frequency domain using fast Fourier transform and reconstruct the image to real domain. For the second task is to apply blue effect to the original image using Gaussian kernel and observe the output change by changing the standard deviation value. So for the last task is to detect the edge of our image using Laplacian of Gaussian kernel. So for more detailed explanation about each task, I'm going to pass to my fellow group members. Thank you.
Very good evening. My name is Yalan Sivalingam, and today I want to present about the task one. And for task one, this is the question for the task one. We should snap an image or one or all of our group members. This will be the original image, and then we should visualize the original image to the frequency domain using fast Fourier transform, and then we should reconstruct the image to the real domain. And this is the code for task one. The first one is for the original image. We declare the image, and then we read the location of the image, and then I'm sure is to display the image, and then we title it as a input image. And then the second the line 8 until the line 11 is the code for the fast Fourier transform image. And then this is the code for the fast Fourier transform. And then I'm sure is to display the transform image, and then we title it as FFT image. And line 13 until line 17 is the code for reconstruct the FFT image to the original image. And then this is the code for that, and then we display the image, and the title display as reconstruct the image, reconstructed image. And this is the output. This is the original image, we title it as input image, and this is the fast Fourier transform image, we title as FFT image. And then this is the reconstructed image from FFT image to the original image. That's all from me. Thank you.
Hi, greeting to Dr. Noor Azlan bin Muhammad Aris.
I am Kirusha Anapurpa Machap. My matter number is B0820102222.
Today I'm going to explain about our signal and system assignment. I want to explain about task 2. In task 2, we have instructed to apply a blur effect on your original image using Gaussian kernel. Observe the changes in the output image as you change the standard deviation value. Compare at least 4 output images with different standard deviation. This is our coding for task 2, MATLAB coding. In first line, we have used kernel 1, F special Gaussian, and the value. F special accept a filter type plus additional modifying parameters particular to the type of the filter chosen. F special uses default values for the parameters. Here the parameters. Same goes to the line 3, line 5 and line 7. And then line number 2, we have used blur 1, IMFilter input image kernel 1. This is kernel 1. IMFilter uses correlation because the toolbox we filter design function produce correlation kernels. Same goes to line 4, 6 and 8. And then the line number 11, I'm show uses to display the image. For we have used input image for the first image. Here the subplot for the first image. Then we have used title for the second image is blur with sigma 2, and then for the third image we have used title blur with sigma 4, and then the fourth image we have used the title for fourth image is blur with sigma 6, and then the fifth image, which is last image for this task 2, we are using blur with sigma 8. And this is the output for our task 2. This one the original image, this one blur with sigma 2, and then this one blur with sigma 4, then this one fourth pick is blur with sigma 6, then the last pick which is blur with sigma 8. That's all from me. Thank you.
Hello everyone, my name is Vaidishari Chandradas. I am going to present about task 3. Task 3 is about Laplacian of Gaussian. Actually, Laplacian of Gaussian is useful for detecting edges that appear at various image scales. The exact values of size of the two kernels that are used to approximate the log will determine the scale of the difference image which may appear blurry image. The question is, detect the edges of your original image using Laplacian of Gaussian kernel. Observe the changes in the output image as you change the standard deviation value. We have compared at least 4 output images with different standard deviation. This is our MATLAB coding for task 3. The function of h is calculate the gradient using the derivative of Gaussian filter. Find edges function in the image filter class, which help us to find the edges in our image. Input image is refers to our original image, and these values are refers to our sigma values. And these codings are for the images. This coding is for the first original image, and the title is input image, and this coding is for our next output image, and the title is log with sigma 0.2, and this coding is for the next image, and the title is log with sigma 0.4, and this coding is for next image and title is log with sigma 0.6, and this coding is for our last output image, which title is log with sigma 0.8. We have also created coding for find edges. This is our coding. Function image smooth equals to find edges, image step size and sigma. Here the step size and sigma value is a default values. This coding is for our original image. And finally, this is for our image smooth coding, and the title is filter image. Finally, we get the output for our task 3. We get 5 images included with original image. This is our input image. This 4 is our output image with different derivative values. This image is log with.
So for next is conclusion. So in conclusion, we have learned how to visualize our original image into frequency domain using fast Fourier transform, and also we learned how to apply blue effect to our original image using Gaussian kernel and comparing into 4 output image to able to observe the change of the output image. And lastly, but not least, we also able to detect the edge of our original image using Laplacian of Gaussian kernel with 4 different output image with different standard deviation. So that's all from us. Thank you very much.